Okay, so far we've just done standard error, standard percent error. Now let's look at sig figs, significant figures, or significant digits. I think that most of you know how to do significant figures. You've probably had this in high school, and I think you probably have it internally, I don't know, assimilated into your brain. But let's go over some rules. So the significant figures are really important, but you don't want to have a lot of extra digits. And when you're reporting your measurements, I know a lot of you will write down what you calculate in your calculator, and your calculator gives you about a gazillion decimal places. You don't want to write all those down if you really only know one decimal place, because if you write down a gazillion decimal places, besides just making your paper really messy, you're giving me a lot of information that is not true. You know, you're lying to me. So we want to represent our data in a way that represents the knowledge that we have of that data, and we do that through significant figures. I'll leave you to read this on your own, but let's look at these important rules to remember when you're reporting and calculating significant figures. You count significant figures from left to right, and you ignore any preceding zeros. So, like for example, if I have 0 to 0.2, you would start over here. You wouldn't count this. So who writes a leading zero in a number like this? And so this would have 1, 2, 3 significant figures. Trailing zeros at the end of a number are significant. This also applies to the number digits reported from the power of 10 when using scientific notation. This is sort of true and sort of not true. So like if I have a digit that is 202, or excuse me, now let's just do 20. If I have a digit that's just 20, this is a significant digit, but this, is that a significant digit? Not significant. So I only know this digit to one significant figure. Likewise, if I have a digit like the 200, this is the only significant figure. However, if I have a decimal place like this, then this, and this, all of those are significant. Or if I have another number after the decimal place, then all 4 of those are significant. Okay, so what you want to do, I think the easiest way to deal with significant figures is to write values in scientific notation. And when you write numbers in scientific notation, like for example this, 2.02 times 10 to the 1, all of these digits are significant. Whereas this, I would just say 2 times 10 to the 1. Or here, 2 times 10 to the 2. And here I only have one significant figure. Whereas down here I would say 2.002 times 10 to the 2. And here all 4 of those are significant. Listen, we'll cover this in the classes on Physics 101 and 201, so we'll spend more time on this in class. But in the lab, it is important that you get the correct number of significant figures. And we'll model that for you as we go through the class this semester, and I'll correct that as I see it in your lab reports. So when you're adding or subtracting, you can have no more decimal places than the original value with the least number of decimals. So say, for example, I'm subtracting 2 numbers, 22.2 minus 21. I would keep the number that has the lowest number of decimal places, and that would be the number of significant figures. So here, this has 0 decimal places, that's the lowest number of decimal places, and it has 2 significant figures. So my final answer should be 2 significant figures. I'm sorry. No, I'm sorry. Let me rewind. This has 2 significant figures and no decimal places. This has 3 significant figures and 1 decimal place. So my final answer will have 0 decimal places. So 22.2 minus 21. If I do that in my calculator, I get 1.2. But I'm only going to report 0 decimal places. So I'd have 1. Let's do a different one. So let's say I have 43.24 minus 20.2. And so if I put that in my calculator, what do I get? 23.04. But I'm going to keep the lowest number of significant figures, which is the number of decimal places that is in the number with the smallest number of decimal places. This has 2 decimal places, this has 1 decimal place, so I'm just going to keep 1 decimal place in this last answer. So the way that I would report it would be 23.0. Now with adding and multiplying numbers, it's a little bit different. You're going to keep the lowest number of sig figs in one of those digits. So let's say if I do 2 times 4, that's easy because they both have one significant figure, so I report one significant figure. But if I do 2.0 times 4 just 4, I would still report 8 because this digit has 1 sig fig, this digit has 2 sig figs, so in my answer I will have one significant figure. And then finally, if I do 2.0 times 4.00, then my answer would be 8.0 because here I have 3 sig figs, here I have 2 sig figs, so I report 2 sig figs in that answer. Okay, so sig figs are really important and we'll cover them in